Hello, pre-calc classes. This is Mr. McAllen. I'm making this video because I've gotten a few emails requesting going over a few of these problems. So I'm going to do that. Forgive my voice and if I cough at all. Anyhow, here we go. So we have you need to know your 5 formulas before we get rolling. So I'm going to just write them up and I'm going to restart the video. Okay, and I wrote up the 5 formulas and remember that tomorrow at the beginning of the test or quiz, I'm going to have you write out the 5 formulas, the 2 for arithmetic, the 3 for geometric, and then I'll check them, and I'll take points, or I'll mark off points at that point, but I'll at least we'll have you with the correct formula. So let's do one of these first problems here where they ask for the first 4 terms. All you have to do for this is plug in the end value. So you need to do A1, A2, A3, and A4. Plugging in A1 value for the first one, you would get -1. Plugging in a 2 value for the next one, you would get 3. Plugging in a 3 for the next one, you would get 12 minus 5, that'd be 7. And plugging in a 4 value, you would get 9. Moving on to, let's say, number 4, you would again plug in 1, 2, 3, and 4, so just be careful when you're plugging them in that you don't miscalculate anything. So we'll plug 1 in here, we'll have 1 minus 6, so it'll be -5 over 7. Then I'll plug 2 in, so I'll have 4 minus 6 over, that'll be -2 over 10. The next one I'll have 9 minus 6, which will be 3 over 15. And the last one I'll have 16 minus 6, which will be 10 over 22. So hopefully that doesn't give you a hard time. Let's do number 6. If we did a to the n and I did the 9th term, that would mean n has got to equal 9. So I just plug in 9 into that equation, and that would be 4 times 9 minus 5, and I think I've got to square the whole thing as the equation says, so that would be 36 minus 5 would be 31, and then I've got to square it. So that is going to be a really big number, and I trust that you could figure that one out with a calculator on your own. Oh, by the way, don't forget to bring your calculators for tomorrow, so have your calculators. The next one, find the indicated partial sum. So let's take a look at this one. We have to add up the 6 terms. So, well, I only see 4 terms here, so I've got to do the next 2 terms. So I have 1 over 9 minus 1 over 27. I have 1 over 81. So I've got to add up these terms. I've got -1 over 243. So it looks like what's happening with a pattern is it's a -1/3 multiple. So my next one would be multiplying the last term by -1/3, and then doing that again to get my next 2 terms. So I'm going to do that. I'm going to pause the video and do that with my calculator and then come back to you. Okay, and I'm back, and I have finished finding the 2 terms because it was a -1/3 ratio, and I added the 2 other terms, the 5th and the 6th, and I got the summation by just adding them up by hand, or you could use sum of 6 terms equation for geometric series. So let's take a look at find the indicated sum. Let's do number 11. So number 11 is first you have to expand the sum. It's only got 4 terms, so you would simply just do it for k equals 1, 2, 3, and 4 and add up those terms. So the first one will be 1 minus 3 over 1 plus 2. Then you would have 2 minus 3 over 2 plus 2, and then you would have 3 minus 3 over 3 plus 2, and then you have 4 minus 3 over 4 plus 2. You find out each one of those fractions, and you add them with your calculator. And what you see is that these two will cancel, and you'll just be left with 2/3. Moving along, we will do, let's say we do find the indicating term of the arithmetic sequence. Let's do number 18. So what we would want to do here, oh, I'm sorry, let's find the common difference. Let's do a common difference problem. Simple, just take what's the difference between these two terms. It would be negative 17 minus negative 12, and that would have to be a difference of negative 5, and that means that the sequence is decreasing by 5 each term. On this one here, you would say that the d value for number 14 would equal positive 5. Moving along to number 18, what's the 19th term? Well, you need to know the first term. Remember the equation, a to the n equals the first plus n minus 1 times d. We need to know the first term value. Well, we have that at 807. And we need to know the number of terms, and they gave us that. That's 19. And we need to know the difference. And the difference here is, I'm going to just use my calculator, and 784 minus 807. And that's a negative 23 difference. And that will give me the 19th term. So I'll just use my calculator for that. 807 plus the quantity 19 minus 1 times negative 23. And I get 1200. That's not correct because it should have gone down. It should have been, I put it in the calculator wrong, so I'll just edit that, and that gives me 393. So make sure you put the information in the calculator correctly. In the next problem set, it says find the indicated term of the arithmetic sequence, or what term number we see with the arithmetic sequence. So let's do the first one, number 20. It wants to know what term a to some value n is equal to 514. Well, you use your a to the n equation. So a to the n equals a1 plus n minus 1 times d. We know we don't know the n value, but we know what the term value is. It's 514. The first term was 1 in the sequence, plus, again, I don't know the n value, but I see the difference is 9, because the difference between terms is 9 points, or 9, it's 9. So you can just solve for that. Some people like to plug in values of n until they get it. I'll just do it algebraically. Divide that by 9. That goes 57 times, I believe. I'm going to check that. And that's correct, and n should equal 58. So that term is a 58th term. So use that same approach to do these other ones in your review. On the next one, find the indicated quantity. Well, let's do number 25. And remember, we wrote out for A13 equals 57. We wrote out 57 equals A1, which we don't know, plus n my 13 minus 1 times the d value, which we don't know the d value. And then for the other equation, we wrote out, if you look back in your notes, the same setup, and this was 16 minus 1. Again, we're using the a to the n equation for arithmetic sequences, and if you simply subtract equations, let's say we subtract them this way, we'll have 12 equals, this is 15D here, and this is 12D, so the difference will be 3D, and you'll end up getting D equals 4, and then you could use that to plug back into your original equation. 57 equals, they wanted us to find A1, so 57 equals A1 times plus 12D, and so 57 equals A1 plus 12 times 3, that would be A1 equals, this is 36, so A1 must be 57 minus 36 is 21. So A1 would be 21. So moving along, find the sum of the first 373 natural numbers. That would be using your sum equation. So we have 373 numbers. The first, that's 373 over 2. The first one was 1, the last one is 373, and that's how you would go about and find that summation. For number 30, you would, the first 23 terms of the series, you would need to find the last term. So your sum equation of 23 terms would equal 23 over 2. You would have 5 for your first term, and you would have to figure out what a to the 23rd was. And I'm going to do that, but I'm going to pause the video so I don't bore you to death, and I'll be back with the answer. So I'm going to be working on right now what a to the 23rd is, so I can sum up the first 23 terms. Okay, well, I'm back, and I found that the 23rd term is 159, so I'm just going to put 159 in there, and I'll use it in my sum equation, and I'll get what the final sum would be. I'll leave that to you guys to work out the rest of that math. Let's look at, given the arithmetic series, number 31. Number 31, given the arithmetic series, what's S of n? What's the sum of 8 terms? So this is like adding up 8 terms. It's just asked a little bit funny, but it would basically be, you'd have to sum up 8 terms. You would know that you have 8 over 2 times the quantity 4, and you would need again to find out what a to the 8th was. So I'm going to pause the video again and calculate a to the 8th using this equation. And then when I come back, I'll plug that final part in. Okay, I'm back, and I found a to the 8th to be negative 24. So then you just have to add up negative 24 and 4. That would be negative 20, and you'll have 4 times negative 20. So the total sum would be negative 80. Moving right along, someone asked me if I would do number 33. So number 33 says find the sum of 52 terms, and again, remember, to find the sum of these terms, you should write them out to make sure that they are arithmetic or geometric. So I'm going to write out the first couple just to see how the pattern goes. And when k equals 1, this is called expanding the sigma notation, and this will be, the first one when k equals 1 will be 496. The next one will be, when k equals 2, it will be 492. And the next one will be, when I put k to be 3 in, it will be 488. So I know now that it's an arithmetic summation, and I can use my arithmetic summation formula, which says s to the n, or s to the, I have 52 terms, because 52 minus 1 is 51. Don't forget to add the 1 for counting the first one. So s sub 52 will be 52 over 2, 52 pairs, and you need the first term, which was 496, and I need the last term, which is A52. I have to plug in, or I could actually just plug in 52 into this equation. So 500 minus 4 times 52, that's 208. So this is 292. And when you finish calculating that, well, I'll leave that up to you guys, but the formula is right there. Now we look at number 35. It's a word problem about a man who earns $3,500 for the first year he worked, and he receives a raise of $500 at the end of each year. What's his salary? What was his salary during the 15th year? So that's basically just asking you what A15 is. They didn't ask us to sum up the 15 years. They just asked us what is his 15th year salary. So you just take the first year was 3,500. That's A1 plus the number of years is 15 and minus 1 times D. So that's the number of years, which is 15 minus 1, and the D value is the raise, is a $500 raise each year. And that would be 14 years, or 14 raises of $500. So I'm just going to do that on my calculator. 14 times. Don't forget again to have your calculator, people. 7,000. So the final amount would be $10,500 in the 15th year. That's what his salary would have been. Now we move along. Hopefully you could do common ratios. Remember, the ratio is equal to the term to the right divided by the term right next to it on the left. And just use your calculator. For instance, on number 39, the ratio is -3. And on so you can verify those with the answers in the back. It says to find the indicated term, so let's do that for number 42. So a to the n for geometric is equal a sum 1 r to the n minus 1. So the ninth term is going to equal the first. Then the ratio between terms is -3, and then I'm going to raise that to the 8th power. And I'll leave that to you guys with your calculator. Just be careful, make sure you put the negative inside the parentheses, and you raise it to the proper power. So now moving along, find the nth or general term. Right here you can see that the ratio is equal to 8, so you can write just a to the n. The general term equation is equal to 1 for the first number in the series times the 8 raised to the n minus 1 power. Last few problems. I'm running out of voice here, but find the sum if it exists. So I look at number 50, and number 50, it's a infinite sum. So I'm going to use the infinite sum equation, the first term over 1 minus r, and in this case I'm going to first check the r value, and when I come back, remember the r value is just by dividing this number, 58 over 9, divided by -29, and seeing if it's less than 1. So I'll pause and then come back and we'll check in. Okay, well, I checked the ratio on several terms, and the ratio, if I divide the one term by the last, it is equal to 0.222, which is less than 1. So now I can use my infinite sum equation, which is just equal to -29 over 1 minus 0.222, and that would give me the sum of, let me just do that on the calculator, that would give me a sum of -37.27. The last one I'm going to work out, and I'm just going to leave the work up for you guys to see, because I have to end this video before 20 minutes. Okay, well, I'm back, and I just want to explain that the ball, it wants to know the upward bounce height, how far upward it goes each time. So you add 3 to 9/4, 27 over 16, 18 over 64, and so on. It's an infinite geometric series, so use that equation, and the ratio is equal to 3/4. hopefully this has helped you, and you get a chance to look this over and use this as for practice for the test. And looking forward to seeing you tomorrow. So study up. Don't forget your calculator. Take care.